Today we were talking about complex numbers and then subsets of the real numbers and then repeating numbers and something that's actually useful. Okay. So a rational number is a number. What is this? 104? A rational number is a number that can be written as a fraction of two integers. Okay, so let's take 0.3 repeating. Is that a rational number or not?
Yes.
Yes. Why? Because this can be written as 1/3. It's a fraction of two integers. Okay? But have you ever wondered, what if I have a repeating number and I want to find the fraction it goes with? Jose does. He sits there every day and he goes, I wonder if I can figure out, Corbin too, I wonder if I can figure out this new math thing. It's like, I want to figure this, like, quadratic formula, this guy was like 30 lessons ahead. He's like, got it. How do we do it? Well, it's actually pretty simple. We use basic, like so basic algebra. Okay, so this signifies the number 0.333333. Right, going forever?
Yes.
That's what that means, right? What happens if I multiply it by 10? What does that equal? 3.3333333333. Right? If you multiply by 10, you just get 10 times that. So if I were to write out this number, that's a good point. Oh, poor guy. And going on forever. Now watch this. This is the cool party trick. This lesson has really little to no actual useful value. Cool party trick. You know, I said some lessons are like, wow, this is so important, you're going to use this every day. And then some lessons like completing the square. Cool party trick, right? No? You're fighting me right now. Is that what's going on? I depend on you for like input and remarks. And like, you're the guy. Every class has one. Right? This section of the room, they're not giving me input. Look. No input. This section of the room, no input. Right here, Zeke maybe. Joseph gives me the face. Like, no, I moved Jose over here, so now he's like below the line of sight. So like, no input. When you were over there, you made it. But over here, no. So, you're the input guy. You have to like, yeah, it's true. You're the guy. You're carrying this class, or you're like, maybe they could start giving input. Why don't you give input? Simon gives input.
Simon gives internal process.
Okay, watch this. Cool party trick. How do you solve this equation for n? Or these two equations for n? Are you ready? Yes. I'm going to multiply this one by minus and eliminate. Watch. What's 10n minus n? What's 0 or 3 minus 0? 3 minus 0 is 3. What's 0.3 minus 0.3?
1.
What?
I need to work on closing my zeros.
What is this supposed to be?
I didn't know they used.
So, n equals 3 over 9, which equals 1/3. Now this is where you should be bothered. Are you ready? Well, this one has one more 3 than that one does. Right?
Say that again.
This one, way down here, has one more 3 than this one does.
Yes.
Yeah.
But it doesn't, because it goes on forever.
Oh.
So like, here is here's like, you know when you go to bed at night and you're like, what happens if I don't believe in Jesus and I die in my sleep? Did you guys ever do that? I don't know, I do that. And I sit there and I'm like, if people don't believe in Jesus, like if there is no after you live, that's it, you're done, right? People believe that. And I go to sleep and I never wake up. And then you play that game with yourself, like, well, would I be somewhere? But I would be somewhere, but I would never exist. But then, like, I would never wake up, but you feel like you're like asleep, and then you would wake up at some point, but then you don't wake up because you're not. It just doesn't work. And then you go, oh, if I die in my sleep, I'm gonna be in heaven with Jesus. And you're like, oh, okay. And then you like go back to sleep, and you're fine, right? But like you wrestle with that. This is one of those things. It's not as important, but you're wrestling with an infinite number of things. And the issue with an infinite number of things is that, yes, although you would think that this would have one more 3 at the end, because we multiply this one by 10, since you have an infinite number of them, it doesn't matter. It doesn't matter, right? Because does this number even really matter if there was a 3 here? No, that number is so small that like 0.00003, it means nothing. So, at an infinite number of 3's, who cares? And you get 1/3. So, what are these problems going to look like? If that bothered you guys, here, do you want your math placement for next year? If that bothered you, and you're like, oh, that's cool, I want to figure out more about this, then you're ready to move up. And if you're like, nope, then maybe not. And if you weren't interested, you should be. Okay. No. Corbin's not giving me the input I need now. There's just no input. All right, let's try another one. So we're going to show that, now this isn't a repeating number. So that this is a rational number. Can we show that this is a rational number?
No. Yes.
Yeah, it's actually really easy. You've already learned this in like elementary school maybe. What is this? This is the tens place. 100, 1,000.
10,000, 100,000, millions, billions, zillions. What?
So it's 623 over 100 million. But using our new method, could we get to the same answer? Yeah, here's how we would do it. We call n our number. Okay, I will tell you this. When I was in Algebra 2, way back when, back in my day, probably before you guys were born. No.
Yes.
No.
I was looking. Wait. You'd be 15. You were teaching in ministry by then.
Yeah. Okay. Anyways, back in my day, while you guys were still toddlers, I didn't understand this lesson. I never understood it. I didn't understand how it worked. I was really mad. It drove me crazy. Okay. So here's what I didn't get. You're in algebra, right? Algebra means we replace numbers with letters. So we're going to replace this number with the letter n. Then I'm going to do something to that letter n to make this problem work. That's all algebra is. It's all it's ever been. We're just playing with numbers that are disguised as letters. Okay? So if I wanted to cancel this out, how could I do that? Well, I can multiply this number n by 100 million. What do I get? 623. And then I can just divide by 100 million. Because I don't have to deal with the repeating part. It's just done.
It's a bit silly.
So n equals that. That's it. But when we get to the repeating ones, it is more complicated. Why did I have to go and make things so complicated? Because it's math. And math is complicated because we have to solve real world problems. So, how do I write this number as a fraction, right? How do I show that it's a rational number? By showing that it can be a fraction. Here's how we're going to do it. I'm going to walk you through it, and then you can contribute on the next one, okay? However many decimal places are repeating, that's what you're going to multiply n by. So here, only one decimal repeated, so I multiply by 10. Now I have two decimals repeating, so it's multiplied by 100. What does that do? That gives me this. Don't worry about the numbers in front, they'll work themselves out. Okay? Now I have 1.61623 repeating.
If you're on a 0.
There we go. Right? Because this number is 0.0162323232. So if I multiply by 100, and it moves the decimal point over 2, and then you get 1.62323232323. Okay? Then you subtract. A 100 minus 1 is 1.62323 repeating minus 0.1623 repeating is what?
1.6.
The repeating part cancels. What's 3 minus 6? Ugly, right? I have to borrow. 13 minus 6 is 7. 1 minus 1 is 0. 6, 1.
Cool.
Decimal point.
Do we do?
Now, in order to solve, I'm going to divide by 99. Leaves the 99. No?
I know.
Okay. Today's Noah Bigley's birthday, so in honor of Noah, I'm doing all the, you know Noah. Sophomores know Noah. I've been playing worship pads all day and then singing reckless stuff. It's great. All right, is this an integer divided by an integer?
No.
No, that's a decimal. How do I make this an integer? Multiply by
100.
1,000, because I need to go 3 decimal places over. So I'm going to multiply by 1,000 on the top and bottom, and my answer is that. So this number can be written as a fraction. Did I do it wrong?
Can you cancel? Or the 9? Yeah.
Leaves the 99. That's how somebody in this room writes their 7s. I don't like it. It looks like a 1.
What?
You know who you are. Anyways. Yeah, but that's how you write your 1s.
That's why I put the 7 like that.
But if there's not one for 2.
It's like you're
Yes, so what are our steps? Write your number. Multiply by however many places are repeated. So 2 decimal places are repeated, multiply by 100, because there's 2 zeros. Subtract, and then make that a fraction. So get rid of your decimal. All right, that's it. You made